All right, now let's look at some examples of using our angle properties, triangle properties, things like that to solve some problems then. So in our first example, it says if angle, and remember this is supposed to be an angle sign, if angle GHI and angle JKL are complementary, what is the measure of each angle? Okay, now this is going to be kind of tricky because here we've got an angle, here we've got an angle. They're totally separate from each other, but all we know is that they are complementary. So I'm going to call this angle H. Suppose I should have the angle plus angle K. All right, we've got this whole angle plus this whole angle. The only thing we know is that they are complementary. Now what would that mean if they are complementary? It means H plus K, this whole angle plus this whole angle, adds up to make 90 degrees. Okay, we had to take this word, complementary, break down and say, okay, these two add up to 90 degrees because they are complementary. From there, now we can start working. This angle H, instead of calling it angle H, we can now call it 8r plus 9 because this is its given angle measurement. Now it doesn't tell us an exact number of degrees. We have to solve for that number of degrees. But we can say it's 8r plus 9 plus this one. We don't know its exact number of degrees, but we know it's 7r plus 6. So 8r plus 9 plus 7r plus 6 must equal 90. Why? Again, because they are complementary. So we need to solve from there then. 8r plus 9 plus 7r plus 6, we can combine those. 8r plus 7r, 15r. Positive 9 plus positive 6, positive 15, or plus 15. So we had to use some algebra to figure that out. From here we can subtract 15 from both sides. That would get rid of it over here. Minus 15 on this side. Well, what would that become then? It would just say 15r equals 75. Okay, we're not quite done yet. We got to get r alone. Divide both sides by 15, and we get r equals 5. So we know that r equals 5. That doesn't necessarily mean we're done, though. We still don't know how big this angle is and how big this angle is. We still need to finish this off. To figure out how big this is, we would do 8 times 5, right? Because 8r, so 8 times the 5 plus 9. This will give us the measure of angle H. 8 times 5 is 40. 40 plus 9 is 49. So the measure of angle H is 49 degrees. So that's one of our answers. Let's do the other one. 7r plus 6, well, we figured out that r is 5, so 7 times 5 plus 6 equals our angle K. 7 times 5 is 35, plus the 6 is going to be 41. So angle K is 41 degrees. These are our two answers then. We can't just stop at r equals 5 because we don't know the measure of the angles then. So, to double check, if this was 49 degrees and this was 41 degrees, 49 plus 41 equals 90, means they are complementary. So these are our two answers. Number 2 shouldn't be as bad. It says, what is the measure of angle STU? So this angle, STU, we need to figure out how big that actually is. Well, this one is right across from this angle. Right? If we have two lines crisscrossing, then the vertical angles, the one across from each other, have to be the exact same, or have to be congruent. So, since vertical angles are congruent, we can say the measure of STU is going to be 18 degrees, just like this other one. You can ignore this. You don't necessarily need to save room. You can go ahead and take up some space. We need to find the measures of angle ABD and angle DBC. So ABD, this one, we need to know how big this is. And DBC, we need to figure out how big those two angles are. We're going to start, again, with what we know. This is one long straight line, meaning it's got to be 180 degrees. These two share, this angle and this angle, share this ray, so they are a linear pair. These two angles, linear pair, they're on the same line, and we know that they must add up then to 180 degrees. So 180 degrees in total is this angle plus this angle. Okay, it's kind of like what we did in the first one. I just skipped the step of writing those angles in. So if you're having trouble where this is coming from, make sure you ask me in class. But 180 degrees, this angle plus this angle. Again, we'll just use some algebra to combine pieces. 3x plus 5x equals 8x. Positive 7 plus negative 3, or a minus 3, comes out to a positive 4, a plus 4. So again, we have to use our properties of algebra to combine these two pieces. This whole angle, you see it right here. This whole angle, you see it right here. We added those together and made it this. Okay, now what can we do from both sides? We've basically turned this geometry problem into an algebra problem. All we have to do is just solve it like we would with algebra, minus the 4 from both sides. So it now becomes 176 equals 8x, and then divide the 8 from both sides, and we solve that x equals 22. Again, we're not done yet. We know that x is 22. We just have to plug it in. So, looking at this should be ABD. For angle ABD, 3 times x, which is 22, plus 7. 3 times 22 is 66, plus the 7. 66 plus 7 is 73 degrees. So we know that this whole angle is 73 degrees. If we plug it in for the other one, for DBC, this angle, 5 times x minus 3, 5 times 22, which we solved over here, minus 3. 5 times 22 is 110 minus 3. 110 minus 3 is 107. So we know that this must be 107 degrees. Again, to double check that these are a linear pair, 73 plus 107 does come out to 180. So these must be correct. Example number 4. Given the diagram, you need to name one pair of vertical angles. Well, if we look at where all of our lines are, we have one long line here and one long line here. This one coming off of it is just a ray, so we're going to ignore that one for this part of the question. Looking at these two sets of lines that crisscross, there are two pairs of vertical lines, here and here. So you can either name that angle INJ or JNI. Goes with angle MNL or LNM. So that would be one pair of vertical angles. There's also another pair, INM or MNI, however you want to name that, goes with JNL or LNJ, however you want to name that. So these are your only pairs of vertical lines, vertical angles, because these are the only two crisscrossing straight lines. You also need to name, I'm going to get rid of some of those, one set of linear pairs. So again, think of where do you see straight lines. So here's an example of one straight line that is cut by this ray. So one example of a linear pair is INJ, or J and I, however you want to name that, and INM, or M and I, again, however you want to name that. These two angles add up to 180, so that would count as a linear pair. There are other ones on here. But that's just a pair. That's one set that would work. We're not going to go through every single one of them. Two complementary angles. Remember, this word complementary means it adds up to 90 degrees. There's only one spot where we have 90 degrees. It's right here. Okay, now technically that also means that this is 90, but we don't have anything that cuts that into two. We do have over here, this is a part of the 90, it's not the whole thing. This is a part of the 90, but it's not the whole thing. So these would be our complementary angles, angles I and J and J and K. Remember, again, you can kind of rename each of those however you want, but it's those angles, I and J, J and K. Those are your two complementary angles. Get rid of those. Two supplementary angles. Remember, supplementary mean they are going to add up to 180. Now, we don't know how big any of these are. There are no angle measures on any of them, except for this one that is a 90. So to say that something is supplementary, we're going to have to find linear pairs, because we know that all linear pairs are supplementary. So I and M and M and L, I'm going to use those ones as my example because here is a straight line. Here are the two angles, so they are a linear pair, so they have to be supplementary. These will add up to 180. Now again, you could also use these ones over here, but I'm just using these ones for my example. Last thing, two adjacent angles. Now again, there are a lot of ones you could pick. I'm going to pick J, N, K, and K, N, L. These are adjacent because they share this ray. That's the only thing that they need to be called adjacent. There are definitely more things on this that you could use for each one of these, but those are the ones that we used. Oops, I think we're missing, here we go. Number 5. Given the diagram and the fact that angle I and J is 63 degrees, we need to find everything else. Well, right now, these aren't necessarily labeled. So we're going to label I and J as 63 degrees. Given that information, we need to start finding some other pieces. So first thing we're going to find is if this one is vertical with this one, remember we've got our crisscrossing lines here and here, which means vertical angles should be the same. I'm going to draw them in the same color as well and show that if this one is 63, this also has to be 63. It has to be because they are vertical angles. Because these two are both going to be vertical angles, then I can say that angle MNL, this last one, oops, has to be 63 degrees. Now, let's find some other pieces. There are a lot of ways you could go to solve this. I'm just choosing to use this little box. If this is a right angle, that means this whole thing is 90 degrees. If this whole thing is 90 degrees and this piece of it is 63, then I'd have to go 90 minus 63 to figure out this chunk. Now what is 90 minus 63? I'm just going to get rid of these. 90 minus 63 is going to come out to 27. So I know that angle JNK, that very first one here, will come out to 27 degrees. So I found two of these. I got to find this one and this one. Well, there are a couple ways I can do each one. I'm going to try it fairly simple. This is a straight line, INL. One big straight line. In fact, I'll just draw it in. And this is a right angle, meaning it's 90. So if this side is 90, this other side has to be 90, because 90 plus 90 makes that 180, meaning this one must be 90 degrees. It's that missing piece. So that tells us LNK, or KNL right here, must be 90 degrees. Now I can also use that same red line right here to show, okay, here we have a linear pair, INM and MNL. If this is 63, this piece must be whatever 180 minus 63 is. Right? This whole thing is 180. Take away this part. Whatever's left over will be right here. 180 minus 63 comes out to 117. So this last one must be 117 degrees. So we can figure out all of these other angles just using what we know. Vertical angles, complementary, supplementary, linear pairs, things like that. These are going to be the types of problems you're solving. Lastly, we're going to go over classifying some triangles as specifically as possible. Now, by specifically, I'm saying everything that we know about them is going to be put in there. Now, when we look at triangle A, and I know these ones aren't on your notes, either draw them in there or just kind of make note of them. Notice that this one, none of our angles are drawn in there. We know nothing about this angle, or this angle. So we can't really say anything about the angles. We can only talk about its sides, 3.5 centimeters, 5 centimeters, and 4.5 centimeters. Because we only know things about the sides, and none of the sides are the same, the only thing we can really say is that this is a scalene triangle. That's really all we know. The only thing we can do is scalene. On this one, we do know a few other things. Given that these three angles are the same, we also know that that must mean these are the same, as we already talked about that. So this triangle is equilateral because of these sides, and equiangular. Oops. Triangle. This one is both. We know things about its sides, and we know things about its angles. So we can use both to name it. And that'll cover it for that lesson.